So it's 9:01, so we will start. So hello everyone, thank you for joining us on this webinar about complex steel connections design using the finite element method. And it's also powered by the OpenSees analysis engine. My name is Marta Franca. If you can, thank you, David. My name is Marta Franca. I'm the business development for CYPE Steel Products. And my colleague is David de Dios. He's working in the development department, and he'll be doing the presentation today. For any questions, any queries that you might have, please, you can email me to my email, marta.franca@site.com. I will put it in the chat later. And one more thing I would like to add before David starts is that you can have more information about Subconnect in our website that David is going to show you now. There, I will share this this link as well through the chat. There you can see that you can download the software to try it for a month, and also you have many resources that you can use to know more about Subconnect and how to use it. And that's all the resources that we have. And if you go back one moment, David, you can see the link to download. So if you click on there, it will take you to our platform BIMserver.center, and you can see there that you can download it directly from there. So it's very easy, and I will share this link as well. So sorry, I'm gonna let David start for the presentation now, but I will, at the end of the webinar, I will come back again to remind you about my email address and to say goodbye. So David, whenever you want, you can start. And also, sorry, you can ask any questions you might have through the chat, and we'll try to answer everything today. But if we cannot answer today, we'll send you an email with the reply. So feel free to ask any questions. Okay. Thank you, David.
Thank you very much, Franca. Hello, everyone. I'm David de Dios, and as Marta has said, I work for the development department here at CYPE. And today we're going to see how we could use Subconnect to design, model, and analyze our complex connections with the finite element analysis with the OpenSees engine included with Subconnect. So today I'm going to show you from start to finish how you would start with definition of your structure, for example, in Site3D or other software that is not able to export IFC files. And then we will be able to see how we can import this data to Subconnect, how to design the connection and analyze it, as well as how to generate the drawings and reports for this specific union. Let's take a look at some of the features of Subconnect. And as you may imagine, of course, it's designed to model steel connections like this one, or for example, this other one, and it allows you to insert all the different pieces of this connection one by one manually. And so, as you may imagine, it gives a kind of flexibility that comes with the definition of the 3D model itself. We can start with a series of operations, as you can see here in the model plan. And all of these operations will be added chronologically here in this operation tab on the left. Steel connections are not the only thing that we can model in Subconnect. We also have the option to design timber or steel to timber connections, as well as connections that have a meeting point with a concrete solution. Let me show you an example here. We have this combined structure that, as you can see, uses both steel and timber, and all of these unions have some kind of interaction between these two materials. Like, for example, we've done here the columns with steel and the rest of the roof with timber. And let's take a look, for example, at this connection here, very standard one made with timber. And as you can see, it's as easy as adding individually the elements. Like, for example, in this case, we're working with this option here with doubles and bolts, as well as plates. As you can see here, we have a plate inserted that allows us to create this connection between these two pieces. And as I said before, this is not the only kind of connection that we could do with Subconnect. We can also create steel to timber connections. Like, for example, let's take a look at this one right here, where you can see that we have joined this column here with all of these beams with a series of plates like this one, or these are plates right here that are welded to the web of this column right here. And as I said before, you can freely customize the operations that we're going to add, its order, as well as the different configurations for each specific operation. And when you finish, you will be able to go to the analysis tab here and get all your results. So let's get back to the beginning of this presentation and let's see how we could do this by ourselves step by step. Let me close this file here. And let's go back, for example, to our main modeling tool for structures. In this case, let's say that you were working with a very simple structure like this one, a warehouse, and you can model this either with Set3D or with whichever tool you would like to use, as long as it can export an IFC file. And some tools like Set3D allow you to design very simple connections like these ones that we can see right now. But you may be asking, what happens when you have a somewhat complex connection, like, for example, this other connection I'm going to show you right now here, which has been also modeled with Set3D. What happens when we're working with somewhat complicated buildings like this one, very singular ones with these kinds of connections? Well, we can export all of this data into a project in BIMserver.center, which, as you will see, BIMserver.center is our solution for all things BIM on the cloud, and it allows you to both hold projects that contain all of these IFC files and coordinate all the efforts throughout all the different participants of your work team. As you will see here, I've already uploaded this structure here, already exported to an IFC file, like so. I can coordinate my work team as well. And here's the IFC file. As I said before, you can generate it either with our software or with third-party software, as you can see here. And once we have it ready in a BIMserver.center project, we will be able to start our development in Subconnect. So let's close this right here. And let's take a look at Subconnect, which you can download on the BIMserver.center store, as we've said before. We would be greeted in Subconnect with this screen, and we can start a new project, for example. And as you can see, we have the option to link it to a BIMserver.center project. In this case, I have created previously this other project that I've told you about. But in case I didn't create a project before, I could create it right now. As you can see here, we can create new project tool. But in this case, I'm going to select the project that I was talking about, which is this one right here. And with this, we will be able to import this model into Subconnect and start working on top of it. I'm not going to do this in real time because I've already done this off camera. So imagine that once I click here, accept, we will be greeted with something like this. As you can see, we have imported the structure that we have generated with CYPE with all the nodes awaiting to be defined. We can change the view of the structure in case this may not appear somewhat clear at first glance. So if we go to view options here, now we're seeing it with axis, but we can change it to the 3D model as well. Now, as you can see, we have all the bars already imported, as well as all the nodes. And that's one of the things that many clients ask us, and it is which kind of sections we can work with inside Subconnect. Well, it all depends on the building code that you have selected at the beginning of your project. As you can see here in the project tab, we have the code section, and we can select some codes for steel and timber that are pre-built into Subconnect. Right now, we have things like the Eurocode, the Indian standard, the British standard, the American one, Spanish ones, as well as the Brazilian one. And depending on which technical code you select, the materials will change accordingly. This is all the technical codes that we have up until now, but in the future, we will be adding more ones pre-built into the software. We can also work with metric units as well as imperial units. And if we go here to the main configurations, you will see that in the units tab, we have both the international system measurements as well as the imperial ones here. For the length of this presentation, I'm going to use international system of units, if you allow me, as well as the Eurocode. So once we have selected our code here, we will be able to set up all the different materials that we're going to use for our construction. As you can see here, we have already imported by default a series of bars, but the project can also be done with other kinds of bars that are not included in the IFC that we have exported. Let me show you in a moment. Sorry for any inconvenience. Let's close this and let's continue with this one right here. As you can see, we can work with different libraries of materials, both the materials, the matter it's made of, as well as a library of elements for each one. So for example, we could set up things like the kind of steel that we're going to use. As you can see, we can customize all the different data for this, like the unit weight, the yield strength, fracture limit, and so on. And the same could happen for the steel for the bolts, the anchors, as well as the concrete that we will add. Same thing applies for the elements, and as you can see, we have a steel section library that works both for rolled steel and tubular steel. And as you can see, we have sometimes already preloaded, like this one's for rolled dies, simple use, and angles. In case we do not have the section that you're looking for, you can edit the ones that we have here preloaded, or you can import a series of libraries predefined here from a series of different manufacturers from around the world. Once we have our materials ready, we can start with the definition of the nodes on itself. In this case, you will see here that we have a panel on the left that contains all the different nodes that have been imported from Type3D or whichever other tool that you have used to generate the structural model, and all of them are waiting to be defined. So let's select, for example, this one right here, which is the one that we're going to model today, and let's start modeling our connection. As we've seen before, the main interface that we use in Subconnect uses these three tabs: the model tab, the analysis tab, and the shapes tab. And that is because when we finish the analysis of our model, we will be able to generate a series of drawings as well as technical reports containing all the analysis that have been put forward. By default, you can see that the sections now are clashing, And we will start adding a series of operations here, as I've shown before, that will allow us to clean these clashes, as well as add some operations to create the connection in itself. Let's start, for example, with an template for section v3. That's easy as selecting this tool right here, and we're going to tell the program to apply this to section v3, and we're going to join section v3 to section v1 right here. We can tell it where we want it to make it flash. Like, for example, we could make it flash to the nearest face or to top, bottom flange or web of section v1. In this case, we're going to join it to the nearest face, like so. And once we have it, we will be able to set up the material with which we'll create this end plate right here. We can select a series of predefined materials, like the ones that we have defined at the beginning of our project, or we could create our very own. As you can see here, we can edit the different physical properties of our material right here. Now that we have the material set up, we can continue with the geometry of our plate. As you can see here, by default, it adds a plate that goes around the limits of our section. But as you may imagine, if we would like to weld this is not enough. So we can add some overhangs as well. In this case, I'm going to add some overhangs to all sides of this rectangle, 20 millimeters to be precise. And now that we have a much clearer surface, we can continue with the rest of the clashes that we have here. To solve this clash, for example, we could use the adjust section operation right here, and we will tell the program to adjust section v2 to section v1 to the nearest face. We can automatically add welds both for the flanges as well as the webs. But for the purposes of this presentation, I will be adding it both manually as well as automatically. For example, we could add them automatically, as you can see here, and we can tell the program if we would like to only apply these welds to one side of our flanges or to both sides of the flanges. For example, let's add it just to the underside, and if we go back here, we'll see that the top part has disappeared. Same thing applies if you go the other way around or for both sides, as well as the welds for the webs. It's pretty self-explanatory, and as you can see, you can customize the different configurations of the welds, like for example the thickness that we're going to use. If it's going to be made on the construction site or in a factory, as well as some initial and final displacements in case you would like to make shorter welds or longer welds. Let me show you an example here. You have welded section V2 on its web to section V1, and we're going to apply an initial and final displacement to this weld right now. For example, let's make it 2 centimeters shorter on both sides. And as you can see, the model changes accordingly, like so. Let's turn off these welds and let's continue, for example, with the welds for section V3. As I've said, we can add these welds either manually or automatically. In this case, I'm going to add it manually so you can see the other option that we have when we're modeling. Let's add some welds with the weld operation here, and we're going to tell the program that we would like to weld section B3. Remember, section B3 is this one right here on its top flange to section or plate, in this case, front 1. And as you can see, it has automatically added this weld both to the front and the bottom of our flanges. We can also set up which kind of junction we would like to use for the weld. In this case, we're using FEA, but for example, if we were working with the welds that we're going to add to the upper section here in V1, perhaps lab would be a better fit. Let's continue with the welding of this section. And as you can see here, we can change the order of the operations, moving it up and down the list, as well as copying it. And that is what we're going to do, so we can save up some time. And let's change the section that we're going to weld to this front plate, for example. Let's change it to the bottom flanges. Let's copy it again. And let's change it to the web. And like that, we have section V3 already welded to the front plate right here. Now,
David,
let's
you
continue.
also have the view options if it's easier for anyone to make transparent any of the parts, like columns and beams.
Of course, thank you. As you can see here, we can show and hide all the section plates that we would add. Like, for example, at the beginning of the presentation, I've shown you another section that was applied to one of these connections. We can also create sections like this one in case we would like to take a look at how different pieces are matching internally, both vertically and horizontally, like so. We can force a projection as well in case we would like to work only with elevations, plan views, and so on. And we can freely orbit around the point, as you can see here in the 3D view. Okay, so now that we have we've welded section V3 to our front plate, we can continue with section V1. In this case, I would like to weld it to this plate front 1. So let's add another weld. And as you can see, it's pretty simple what we're doing right now. So let's select section V1 and let's weld it to plate front 1. And as I said before, we can tell the program which kind of junction we would like for this weld. And in this case, the fillet one is not available, so we would have to work with this lab one right here. Let's change it to the bottom flange. And as I said before, if it were needed, we could add multiple initial and final displacements for this weld right here. Let's say that you would like to add a different displacement at each side of this weld. You could do that if you were to copy this operation. And instead of applying it to one side, we could add it to on a given edge, as you can see here. For example, in this case, for weld 5, we are only applying it on a given edge, and that is edge 1, this left one right here. Let's delete this, and let's continue with the welds. Okay, so now we have section V1 already welded to this plate that we have created for section V3. And now let's see the possibilities that we could have to weld section V2 to section V1. If you look here up to the operations tab once more, you will see that we have another trimming option, and that is the trim section option. And this allows us to add a trim to the section, as you can see here. You can select section V2, and we have different types of trims preloaded, like for example, straight ones with curve radius or with drill. And we can set up the different geometrical properties of this trim. In this case, for example, I'm going to work with a curve radius, and we can set up the length, the height, and the corner radius. Let's mix things up a little bit so you can see what I'm talking about. In this case, I'm going to leave it, for example, at 50 millimeters, like so. And if I wanted to, I could also copy this action and added it to the lower part of my section as well. Just a matter of changing position to the bottom part, like so. This is very useful in case we would like to add a rotula between sections V2 and V1 in case we wanted to make an articulated section like this one. And now you may be asking, how are we going to join section V1 to section V2? Well, we also have another operation called plate, as you can see here. Then we can add either freely with free space, so we can create connection plates as a kind of stiffener, for example, or we could add it to one of the sides of our section, and that's what we're going to do. Let's select the material first. And now we can tell here in the position tab which type of plate we're going to add. In this case, as I've said before, we're going to work with an attached plate, and we're going to attach it to section V2 on its web, like so. We can add some displacements as well. So as you can see here, we have a series of X and Y axis. So we can move this plate accordingly to this axis to section V1. So for example, let's add an horizontal displacement like so. And we can change the geometry of this plate as well. As you can see, we can change its thickness, width and height. Let's make it, for example, a little bit taller. And we can change which type of material we're going to work with. In this case, I'm going to work with a rectangular plate, but in case we're going to work with a polygonal one, you can see that we can add a series of nodes to this polygon, and this will define in a 3D space how my plate is going to look like. Let's switch back to the rectangular one, and let's continue with the connections. Once we have plates, we can add bolts to those plates, and that's what I'm going to do right now. So if we go to the operations tab once more, it's here that we have the bolts operation here. Then we can add two sections as well as plates. In this case, I'm going to add it to plate 1, and I'm going to bolt it to section V2. We're going to bolt it on its web. And now you can see here that we have two axes, X and Y axis, centered around the plate. And those axes will allow us to add all the different bolts. We can add them manually, like so, or we can add them with the help of this generator that you can see here. This drawing coincides with the axis that we're seeing here, both the X and Y axis, and the different distances are in regards to both the origin of this X and Y axis, as you can see here, SFO, SCO, and the rest of the distances are between the different rows and columns. For example, in this case, I would like to have 3 rows with 1 column, and I would like to separate all of these 44 millimeters. And the SFO is going to be minus 44. This way, I'm going to center all my bolts around this centerpiece right here. So let's click accept. And as you can see now, we have the bolts already added with the separations that I was talking about. We can tell the program which type of bolt we would like to add, as well as the material. And in this case, the materials that we're going to work with are the ones related to the bolts that we have set out at the beginning of our project. Let's select this one, for example. And we could reverse the direction as well if we wanted to here. You can see that it also adds the end bolt as well, the nut, that is. We are almost there. So now we're going to model our last weld, and we're going to analyze our project. So let's add another weld right here, and let's weld this plate, plate 1, to section V1. On its web, it's going to be a FEA, and that would be it. Now we have our connection ready to be analyzed. For simplicity's sake, I've done this very simple connection, but as you may imagine, these are not the only operations that you could apply to a connection. So let me show you, for example, other tools like, for example, stiffeners that we could add on the web of this section. For example, let's apply it into section V1, and the position is going to be section V3, like so. And we can set the direction of this stiffener. As you can see, it automatically adds the welds as well as the plates for the stiffeners, and the geometry of the stiffeners is adapted accordingly to this section that we're going to add it to. In this case, I'm going to make it a local type, for example. And we can tell the program if we would like to add it to all the flanges or only to the center, as well as the slope that we would like to add. For example, let's make it perpendicular on which side we would like to apply this operation. For example, only on the left, the right, both sides. And as I said before, this operation also has these welds automatically added to them, and it works exactly the same as the manual ones that we have inserted before. Another operation that we could add, for example, is openings, and we could add an opening, for example, to section V2. So let's select section V2. Let's make it a circular one, and let's displace it, as you can see here, on the x-axis. For example, 800 millimeters. And we can change the diameter as well for this circular opening that we're going to add, or we could work with a polygonal one if you want to. Just like I've shown you before with the plates, it works exactly the same. It's a matter of adding a series of nodes, and these nodes will create the bounding edges of our opening right here. So let's delete that. And last but not least, we can add anchors as well. And let's imagine, for example, that one of these sections was hanging or was fixed to a concrete pylon. We could model the concrete that we're going to create for our section as well. And we can add the anchors here. So for example, let's add these anchors to section V3, for example. And as you can see, we can set them to be, for example, on the bottom flange, top flange, or the web. And we can set up the concrete that we're going to use. As I said before, we could be defining the element, or we can use a selection of pre-built ones. And just like we have done before with the bolts, we can add the different anchors, either manually, like so, or we can add them with the help of this tool here, the generate tool. We can set up also which kind of anchors we would like to add. So for example, in this case, you have multiple ones for the top part as well as the bottom part right here. And we can change the different physical properties of this anchor, as you can see, like for example, the anchoring length. Okay, so now that we have our section ready and that we have taken a look at different operations that we could add to the section if we wanted to, we can continue with the analysis tab right here. The loads and the load cases can be either read from our IFC file, or we can customize it, as you can see here in the analysis tab. Same thing goes for the loads. We can manually change the loads for each load case, and we can add them manually even if we wanted to, like this, for each different section. In regards to design options, as we have said at the beginning of this webinar, we're working with a finite element analysis engine, that is the OpenSees engine. And what will happen is that we're going to discretize all of these elements into little triangles, and each one is going to have a maximum size of 40 millimeters, for example. If you were to make a smaller size, the analysis would take up more time, but perhaps the results would be more accurate. It all depends on what kind of results you're looking for. But for most of the time, I would say that with 40 millimeters is more than enough. And so once we have the load cases, the loads, and the discretization size ready, we can analyze this connection. Going to click analyze, and now is where everything goes completely wrong and I end up looking like a fool indeed. Let me show you all of this ready. And we have here the results ready to be analyzed either visually, as you can see here, with things like the maximum demand capacity ratio or the volumetric stress, the deformations, the displacements, and we can change the scale if we want to exaggerate what's happening inside the structure, but perhaps a smaller one. And we can take a look at the deformations of our structure. As I said before, we're working with a discretization based on shells, and both the plates and sections are being discretized into this. Other elements, like for example, the welds or the bolts, are not discretized as shells, but rather as springs or points, as you can see here. We can generate a summary with all of this information. That is the sections that we're using, as well as the welds, the bolts, the forces, and some basic data about the checks. Or we can generate a full report with all the checks that have been made by the program, as you can see. For each individual element, a series of checks will be put forward, and as you can see here, for example, we have checks both for the sections as well as the plates and the bolts.
David?
Yes?
Is it not a typical question that they ask you if the analysis of the elements is linear or non-linear? Maybe you can explain.
Well, in this case, we are using the OpenSees engine, and the OpenSees engine for this section that we're seeing right here works with a non-linear analysis of the geometry.
Okay. This is a typical question, no? People ask this.
Thank you very much, Marta. And in regards to the analysis, as you can see here, we have both the finite element analysis with this non-linear approach, as well as the different checks that have been put forward for each individual element in regards to the technical code that we have selected for the analysis. You can see here that when we export the checks, you can take a look at all the different articles and formulae for each specific element. Like for example, shear resistance of the bolts, you can see that it cites the technical code as well as the article and the formulae with all the different calculations being shown step by step. All of this can be exported into PDF files as well as Word files, HTMLs, and so on. Or you could print it if you want to. So now that we have finished with the analysis of our model, we can generate summaries and checks, or if we want to, we could generate sheets, that is drawings containing all of this data. And if we switch to the Sheets tab here, we would start with an empty sheet like this one, and we would be able to populate it with drawings and drawing elements, as you can see here. We could start with a library of templates in case we have a template ready with some title boxes, for example. And from then on, we can set up the styles that we're going to use for the different drawing elements. Like, for example, lines, as well as the text, the fields, and the dimensions. These will be very useful when we are compositing our drawings, as you can see, because we will be able to change on the fly which style we're going to use for each element. Like, for example, here on the drawings element tab, I have selected the line tool, and I can set up which kind of styles I'm going to use from the ones I have created previously in the styles tab, as well as using a customized one in case I want to create this very specific line here. Once we have set up the styles, we can continue in the drawing elements tab here with the scenes. We can create a library of scenes, that is of views of our section, as you can see here. And all of this can be done automatically, or you can create them by hand, like so. Let's create, for example, a new view, and let's add, for example, a section on the y-axis. Let's force a view, for example, an elevation. And let's give it a name. And with that, we would be able to use this scene later when we are adding the scenes to the drawing. We can also use the Insert Predefined Views tool, and as you can see, it will automatically generate all these scenes that we've seen previously, and will add them automatically here to my sheet. We can customize these drawings, as you can see here, with the Edit tool here, and we can work with the scenes here that we have created previously. We can change which kind of view we're going to use, for example, 3D view, front elevation, planned, or side elevation, as well as the scale. We have some predefined ones, as you can see here. For example, we can work with a 1:20, or we can work depending on the zoom that we're using for this specific window here. We can also work with color images as well as black and white monochrome images, and we can set up some other configurations that will be useful when we are generating our final drawings, like, for example, the image quality when printing, as well as the backgrounds. In this case, we can work with transparent or solid white, and some other doodads, like, for example, adding frames and so on. I'm not going to bore you with the details, so I'm going to show you an example of a sheet that has been already composited by hand. So let's switch to it. And as you can see here, we have some new elements appearing. Like, for example, we have these tags or these measurements. Then we can add here in the drawing elements tab, like, for example, the smart tag. We can add a type of tag that will automatically read all the different data from these elements that we have imported from the IFC file and that we have generated in the model tab. So, for example, we can tell it to show the name and values of attributes on only the attributes, like so. And if we select, for example, this section, you will see that it automatically adds the data, like its name and its characteristics right here. We can also set up which styles we would like to use. And as I said before, it's a matter of setting these styles here in the Styles tab. And this not only works for sections, but it can also work for other elements that we have added, like, for example, the bolts that we have here. the welds, plates, and so on. As I said, we can also add dimensions, and these dimensions will be read from the BIM model. So we can make them real distances, or we can make it an apparent distance, as you can see here. In this case, I'm going to work with real distance. And let's add, for example, some dimensions here. As you can see, this also works with styles. So we can create a customized style, or we can use one of the array predefined ones. And we can change the properties of each one of those here manually. And we can also modify the geometry of each element. Like, for example, we can set up where we would like to show the lengths, start and finish point, and so on. We can also add text as well. And the beauty of the text is that we can use also variables, as you can see here. Variables are a series of sources that are predefined in the program that you can reuse throughout our sheets. So for example, if you click here in the available variables, you can see that we can add, for example, variables like the sheet number, or the name of the scene, the scale, and so on. So for example, if we were to add the sheet number like so, and click accept, you will see that it automatically adds the name of the sheet. But if we were to add or copy this sheet, you will see that in drawing 2, the number has automatically updated to tell that it's sheet number 2. We can create a substitute text like this one, also customizable to user variables or predefined variables like the ones that we've seen. And it's a matter of setting its value as well as the user we're going to apply. For example, you can see here that we could create a new variable called, for example, author. We can set a value for this specific project, like for example, David. And you can see that the use will be with these ampersands at the beginning and at the end of this string. Let's click accept, and let's add a text with this available variable. And you can see that it automatically updates. So I can have multiple sheets with all of this data, and I wouldn't have to redraw them by hand, but instead I could go here to substitute text and change the data. Let's say that we're going to change the value to Marta, for example. And you will see that it automatically changes all of this data for all the different sheets. We can work also with multiple sheets at the same time. So we can create groups of sheets like this one. And we can manually add more sheets to each individual group. You can work with different formats that are pre-built by default. As you can see, we have the Dean series as well as the ANSYS series. And as I said at the beginning of this presentation, we can also add templates. We can group all of this data in layers, just like we do with other CAD software. And the layers can be either blocked, so we aren't able to change all this data, or we can hide them, so they do not conflict with the rest of the drawing and help us understand better what we are working with the rest of the layers. Let's continue, for example, with drawing elements. And last but not least, we also have this section tool right here, which allows us to create a section, as the name implies, in case we have not created it here in the 3D scenes tool. For example, let's add a section right here. And as you can see, we automatically add this viewport here with this scene ready with the section on the height that we have set here. And just like before, we could populate this drawing with other data, like for example, the dimensions, as well as lines, smart tags that we have done before, and so on. When you finished with the definition of your drawing, you can export this into PDF, DXF, or DWG files. And if we go here to the print tool, you will see that we can tell program which sheet we would like to print, as well as to which printing device we would like to send this. As I said, we can work with PDF files, DXF, DWG, and so on. I've already done this off camera. So imagine that now I click here on Object, and let's take a look at how the final drawings would look like. As you can see, we're working with vectorial drawings. They are easily scalable and they do not lose quality when we are zooming into them. Now, let's say that you finish with the definition of this connection and you still have to define the rest of the connections for this building. You may imagine that this could be somewhat tedious, but the thing is that we also have, if we go back to the model tab, a series of tools for creating custom libraries, and you could import or export all of this connection data into your custom library. As you can see here, I've already done this, and it would be a matter of easily exporting it, giving it a new reference. So for example, new connection, and you will see now that we have it here ready in the connections library. And if I want to, I could import this into this specific connection, like so. Now let's say that we finished doing this all throughout our model, and you may be asking, how can I create a report that contains all of this data? Well, if we look at the top left side of this window here, we can create a report for all the connections that we have defined here. And as you can see, we can tell the program which connections we would like to create this final report. You could select them all by default, and we can set up the chapter numberings as well with manual numberings or default automatic ones, like so. And if we click accept, you will see that we will automatically generate this report with all the data for all the check summaries that we have created for the different connections. For example, if we take a look at this connection right here, let me show you.
It's a long list, David.
It's a very long list, of course. You can see that all the data for all the connections has been exported, and we can export all of this data easily into a PDF format, as well as Word, HTML, and so on, as well as printed it, that is. And with all of this done, we would have finished the design, analysis, and reports of our connection. And if we wanted to, we could share all of this data into an AFC file with our colleagues in BIMserver.center if we use the share file here, share tool, that is. And
David, there's a question that you might be able to answer. Is someone, Erwin Pose, I don't know if I pronounce it properly, ask, is it possible to offset being V2 from the connection you were doing from its start position from the analysis model? For example, to align top flanges of V1 and V2. You can read it if you want. Yeah.
Of course, you can set up the libraries or materials that you can use throughout the model, and you can change the sections that you're going to work with in each connection. So for example, if I were to edit this node right here, you will see that we can set up which node, how the node is going to work. We can change the section. So for example, instead of working by default with this section, we can change it to be a timber or a steel one, or we can change the section series that we're going to use. Like, for example, we can turn it into an L or a C. We can change the section that's going to be used for this family. Like, for example, we can use one of the preload ones here, so we can make it bigger or smaller. We can change the material as well with the ones that we have predefined. And last but not least, we can change the layout of this section. So for example, we could change it to be a little bit higher or a little bit lower in the z-axis, like so. Let's make it, for example, 20 millimeters higher, or we can make it 20 millimeters lower. We can also do the rest with the rest of the axis, the x and y axis. We can switch it to one side or to the other.
Yeah, so you can personalize.
You can customize the disposition of all the nodes, as well as its composition, as you can see here, for all nodes.
Mm-hmm. For all the parts. Yeah.
Mm-hmm.
Okay, perfect. I hope that's your question answered, Erwin. So it's been an hour, so I think it's plenty of information to have. And if you want, we can just say goodbye and say thank you to everyone for. Let me put my camera on. Okay, so yeah, thank you very much to everyone for joining us in this session about Subconnect. If you have any other questions, any other queries, you can send me an email. If you show the slide, please, to marta.franca@site.com, and we'll be happy to help with anything. And that's it. That's all from me. So, and thank you very much, David. It was a great presentation, very in detail. That's very good. So, yeah, thank you very much for being there. See you soon.
Thank you very much for having me here. I hope this has been useful for you all, and see you all in another occasion.
We will send you the recording anyway, so you'll have it again if you want to go through it, if you want to see it again. Okay. Thank you. Bye.